Okay, guys, 2.5. It says proving statements about segments and angles. So we're going to be dealing with some more geometric proofs. Also, some algebra still will be involved. So our goals, our objectives today is to write 2-column proofs and then to name and prove properties of congruence. Probably not so much that last one. The first thing we need to do is identify what a proof is. Okay? A proof is a logical argument that uses deductive reasoning to show a statement is true. Is this, Brooklyn, is this?
It just shines right through.
It's right through it. Oh. Okay, we've talked about inductive reasoning. What's inductive reasoning? What is inductive reasoning? Turn to someone next to you. Go. What is inductive versus deductive? Go. Inductive, what is it?
I have no clue.
What did we do in section 2 with patterns? Inductive, what is it? I believe I talked about it. I don't know if it was a huge thing we talked about. Inductive reasoning is using your observations to make a conjecture. Okay, it's all about what you observe. There's nothing that's absolutely proven about inductive reasoning. There's no facts. Okay, so if I was a lawyer can't really use inductive reasoning because there's no facts and evidence behind it. Okay, deductive reasoning, that's when we're going to have some facts to back us up. Okay, so in a proof, the proofs that we did last class, when we'd solve an algebraic problem, we would do a step, and then we would have our fact or our evidence to go with it. Okay, so here we go. We're going to look at this first proof. You can see it's two column, and we're always going to be given something. Okay, now sometimes it'll say, hey, given this, prove this. Okay, this one doesn't, but we've got this picture here where I've got 3 segments, WX, XY, and then YZ. And we're given some expressions there. Now, in our given information, let's dissect this a little bit. It says that segment XY is congruent to WX, or segment WX. So segment XY right here is congruent to WX. So that is congruent to that. Okay? And then it says that YZ here, YZ, segment YZ is congruent to WX. So if this has 1 tick mark, what should this have? 1 tick mark. Now, what do we notice about all 3 of those things? They're congruent. Okay? Now, here's the problem with proofs. We have to, step by step, show every little detail. Okay? We can't assume anything. We need to act as if someone who knows nothing about proofs, nothing about geometry, is reading this proof. Okay? Just like a lawyer has to prove that the jury, these guys are average men and women that really maybe don't know much about law and whatnot. They have to prove the lawyer has to prove without a shadow of a doubt. They have to think without a shadow of a doubt that that person's guilty. Okay? So what should we do first? Kira? Write down the given information. Excellent. No matter what the proof is, it doesn't matter. We have to write down the given information. So go ahead and do that. All right, what do you guys think we should do? Say it again. Before we get to the equations, let's think up here again. XY. XY is here, right? And that is congruent to WX, which is this one, right? And then it says that YZ, which is here, is congruent to WX. Here's my question. We're given this expression and that expression, but does it ever say that those two are equal?
Yeah.
Where does it say that at? It never talks explicitly about XY and YZ, does it? They're using this guy, WX, to connect the two. You guys see that? Now, I think we can say here, and we all know that XY, this segment, is congruent to that segment. Because we made the tick marks, and I think we all see that, but we have to spell it out. We can't assume anything. Now, if they're both using WX to connect them, what property is that? Think about it, don't shout it out. What property connects them? Turn to the person next to you. What property is that? All right, show of hands. What property is it? Show of hands. Don't shout it out. Allie, what do you think? Transitive property, absolutely. It never says that XY and YZ are equal, but they use the fact that they're both congruent to WX to make that correlation. Okay, so here's what we're going to do. I'm going to state that XY, segment XY, is congruent to YZ, segment YZ. Our reason? Well, that's the transitive property. If both of these segments are congruent to WX, well then they're connected, or they're congruent to themselves, and that's the transitive property. Okay, now this next one's completely new. Guys, and this may seem silly, we want to make this statement. Now, what have I done there? Jesse, what did I do? Okay, now I'm not talking about segments anymore. Well, without those, it means the length of. So I'm talking about the length of XY is equal to the length of YZ. Now, understand, we're writing this as if someone who has no clue about geometry is reading this. So maybe they don't know what the congruent sign means. Okay? Now, our reason for this is the definition of congruence. Okay? And sometimes we'll use that just, hey, the definition of what congruent means. Congruent means they're equal. Okay? So I made this statement. I haven't changed much. I just said, hey, the definition of congruence. That's why we can make that statement. Okay? Now, this is our framework. We need to understand how we can set them equal together, transitive. We can understand why we put the lengths of are equal. Now that I have this framework, I now can put 4x plus 3 in and 9x minus 12 in. Okay? So instead of xy, I'm going to put 4x plus 3 equals, and then 9x minus 12. What's my reasoning there? What's my reasoning? No? Guys, would you agree that I haven't changed anything? All I've done is taking something and plugged it in for something else. Mary Beth? All I've done is substituted. Yep, I got the same statement, but now instead of xy, I have 4x plus 3. That's substitution. Now let's solve this thing. Serena, how am I going to solve this? Can we combine like terms, Serena? Why? Great, they're not on the same side. So what should we do, Serena? Sure, we can surely subtract 4x to the same side, or from both sides. You know, so subtract 4x. Maybe you would have done it differently. You surely can. Maybe this is like, why are you subtracting to the right? You can surely do it different ways. So then I'm going to get, step 5, I'm going to get 3 equals 5x minus 12. Then from here, Dean, what should we do?
Add 12.
Great, I'm going to add 12 to both sides. So step 6, I'm going to get 15 equals 5x. And our step 5 there. Oh, I forgot my reason for step 5, didn't I? How did I get from 4 to 5? Yeah, subtraction. That's my fault. Sometimes I get a little ahead of myself. That's a subtraction property. And then from 5 to 6, I added the addition property. And then lastly, what would we do? Yeah, x is going to equal 3, and that's going to be the division property. Now, I think once we get our framework in, the second half's pretty simple, but it's that first part that might be a little bit new. Any questions on this one? Okay, let's move on. Example 2. It says, we're given this picture. We've got PQ and then QR, and it says that PR equals 46. Now, guys, if you're given something that's not directly drawn or labeled on the diagram, I usually tend to do that. So I usually, if this whole thing equals 46, sometimes I'll do something like this. Say, hey, that whole thing is 46, just to let me know what that means. Okay, now we can see here that we're actually trying to prove something. Okay, so it says we're given that PR equals 46, and hey, we're trying to prove this. Okay, so given that this guy was at McDonald's, or given this guy knows a few people that got him in trouble, we're trying to prove he's guilty of murder. I don't know why I always go back to that, but I do. That's what we're trying to prove. We're trying to prove that PQ equals 19. So the first thing we're going to do is write down our given information. And I don't know if you ran out of room last time. I kind of did, so maybe we should write a little bit smaller and closer together. Now here's just a little hint. Anytime you're adding segments together, which essentially we are because we're talking about PR, PR is the whole thing, right? We're going to add the first part of the segment plus the second part of the segment. Have we talked about that before in this class? Have we talked about adding segments together? Remember when I was talking about Subway? Anyone recall what that's called? When I'm adding segments together. I see Elizabeth dive into her notes. I like that. Let's dive in our notes. It should be in there somewhere. Should be in there in chapter 1. In chapter 1, Elizabeth's found it. We're going to wait till everyone else or a few other people find it. Dive in our notes. We're adding segments together. It's from chapter 1. Not doing us any good out there, are they? Bring them all aside. Anyone know it besides Elizabeth? All right, we'll keep waiting. The segment addition postulate. Segment addition postulate says, hey, this part of the sub plus that part of the sub equals the whole entire sub. Okay? So we're going to say that PQ, that part of the line, plus QR, that part of the line, equals PR, the whole entire thing. PQ plus QR equals the whole thing PR. And we're going to call that the segment addition postulate. Now, do I know what PQ is? PQ is 2x plus 5. Do I know what QR is? That's 6x minus 15. Do I know what the whole entire thing is? 46. So we're just going to now use this as our framework to replace and fill in. So I've got 2x plus 5 plus 6x minus 15 equals 46. What's our reasoning there? Joey? Substitution, you bet. Casey, how am I going to solve this? Combine like terms. I'm going to get 8x minus 10 equals 46. Our reasoning there? Combine like terms. Yes?
Never mind, I missed that part.
Okay. Now, how am I going to solve this one? Maddie, can you tell me the next step? Sure, add 10 to both sides. So that's going to be the addition property. (8x equals 8x equals 56). Dawson, last thing we should do. Divide by 8 on both sides. Great. So x then is going to equal 7, and that is the division property. Questions, comments, concerns there? All right, so we're given this triangle JKL, and we're given the fact that LK is 5. So over here, again, if we don't know something or if something's not labeled on our picture, we should do that. JK is 5. Oop, LK. It says LK is 5 right there. And then it says that JK is 5. And then it says that JK is congruent to LJ. So JK is congruent to LJ. And we're trying to prove that LK is congruent to JL. What should we do first? given information, right? Okay, now, looking at the first two parts of our given. It says LK equals 5 and JK equals 5. What do we know about LK and JK? Both equal 5, which means they're congruent. Does it say that? Does it say exactly that? No, we can imply that and we know that. But the problem is we have to spell it out for everybody. Okay? Imagine the person that's reading this proof doesn't quite know it all. So we have to spell it out. So we're going to say just that. LK is equal to JK. What's our reasoning there? Congruence? No. We're going to call that the transitive property. Because LK equals 5 and JK equals 5, so from that information, since they both equal 5, well now I can say that JK or LK equals JK. Okay, so from those two statements, well now I can make it a third statement. That's transitive property. Kristen, do you have a question?
Yes. How come we didn't start out with JK and JL because they're congruent when they still be 5? Because now that we have...
Okay, slow down. You said which ones?
So, because JK and JL both have tick marks, that means that they're congruent. Well, if they're congruent and they're same distance, then they'd be 5. How can we start out with the other side? Wouldn't there be 2 ways to do it?
And I will say this, there's never one way to do it. Does that make sense? There are multiple ways of doing these, yes. Depending on the order, the big thing we can't do is we can't just skip steps and we can't assume stuff. But yeah, we potentially could have started that way. I just have to see it. Okay? Talk to the person next to you. What can we say now? Go.
We can say that 5 equals 5 because of substitution. I think I'm not for sure.
Can I say one thing, guys? Constantly, if we're given something to prove, we need to, throughout the course of the problem, always relate back and go back to what is our goal. Okay? Sometimes we get lost in just doing the proof, but we forget what we're trying to prove. Okay? So we're trying to prove that LK is congruent to JL. Okay? Now, if you notice, here it is like in it's in segment notation where it says, hey, segment this is congruent to segment that. You guys agree with me there? Right now, we're not talking about segments, we're talking about lengths of. So we kind of need to convert if that makes sense, from talking about lengths of back to segments. Follow me there? How do I do that? I think we did it earlier. I think we went from segments to the length of. Definition of congruence. So use the definition of congruence when you need to go from, hey, lengths of something to segments, or segments to lengths of something. So I'm going to make this statement. Segment LK is congruent to segment JK. That is the definition of congruence. So we're going to use that. Okay, that kind of acts as a tool that we have now in our toolbox. We're going to use that. We need to change from segments to the length of, and the length of to segments. Now, do I have, in step 3, do I have what I'm trying to prove? I don't quite have what I'm trying to prove. I'm trying to prove that JK is congruent to JL, but I have LK is congruent to JK. All right. Have we used this yet? We haven't used that idea at all yet, have we? And that's why we got these tick marks here. Now, how do I use this statement right here and this statement right there to make this statement? Rachel, have her head up, please. Thank you. How do I go from LK is congruent to JK and use JK is congruent to JL to make that statement? Kristen?
It'd be kind of like if LK is congruent to JK and JK is congruent to LJ, then line segment LK is congruent to line segment LJ.
Would you guys agree that LK is congruent to JK? It says that.
Made the transition.
Okay, and then JK, this part here is congruent to JL. Well, JL is what we need in the end. So really, that's acting as like the transitive property. Okay, we're using this statement. Well, then it says, hey, JK is congruent to JL. So then we can say that LK is congruent to JL based upon the transitive property. Get this middle guy out, essentially. Get the middle guy out. So I can say that segment LK is congruent to segment JL from the transitive property. Now, some people are probably sitting there right now like, Michelle, how do you expect us to know that? We've never seen it before. Well, now you have. Okay, so by doing a bunch of these, I introduce you slowly to methods and ideas of what to use in our proof. Otherwise, you have no idea what to use. Okay? How many do we have left? 2 more? Is that right? 2 more. Okay. Now, our goal is to find x. So basically, you could say, hey, prove what x is. So we're given that angle AOM and angle MOC are supplementary. Let's write those down. Angle AOM and angle MOC are supplementary. Now, we have to assume the person reading this proof doesn't know anything. So, raise your hand if you know what supplementary means. Hopefully our hand's in the air. But the person reading the proof doesn't. We need to spell that out for them. What does supplementary mean? Caden, what's supplementary mean? They have to 180 degrees. So here's what we're going to say. I'm going to say angle AOM plus angle MOC equals 180 degrees. Caden, how'd you know that? What's our reasoning there? Kristen? Hey, that's just what I told you, right? From the get-go, I said, hey, supplementary means 180. That's just by the definition. Since we know the definition, we can state that. Again, so now I've got that framework. Now I know what angle AOM is. AOM, that's 2x plus 30. And I know what angle MOC is. That's x. So let's fill that in. What's my reasoning there? Substitution. Julissa, what should I do now? 2x and x, so I'm going to get 3x plus 30 equals 180. My reasoning there? Hey, Owen, do you know?
What?
My reasoning for that step?
Combine like terms.
Yep, combine like terms. Camden, now what? Yeah, we're going to subtract 30 on both sides. So I'm going to get 3x equals 150. That's the subtraction property. Brendan, then what?
Divide by 3.
Divide by 3 on both sides. X is going to equal 50. And that's going to be the division. Guys, I think I made a mistake up here. My last one. Nope, 2 ago. It just hit me. This one. What's my mistake? Serena, what's my mistake? I didn't prove what I was trying to prove. Did I? My last statement said, hey, x equals 7, but I'm trying to prove that PQ equals 19. So, how am I going to say that? Or what do I need to do, first of all? Yeah, plug it back in, right? So I plug in 7 here. I'm going to get 2 times 7, which is 14. 14 plus 5 is 19. So, I'm going to say PQ equals 19. What did we do there? Jordan? I think we substituted 7 in for x. Kristen?
How come you didn't write down the problem by replacing 2 times 7 plus 5.
If you want to, but at that point, that's our answer. Then that would have taken like 3 or 4 more steps. I don't need you to do that. Yep. Once we solve for it, I don't need you to keep going. Okay? I don't know why I remembered that, but I just did. Moving on to the last one here. So let's write our given information down. If someone with zero geometric knowledge reads this, are they going to know what bisect means? No, they won't. So we need to spell that out for them. What does bisect mean? Splits it into 2 equal pieces. So how can I write a statement like that, revolving around this problem, that defines what bisect means? Talk to the person next to us. Go. What do you think?
RAB is congruent to BAN.
Good. I like that. And I would just say angle in front. Angle. Listen to Rachel here. Rachel, what do you got? We know that if it's bisected, the 2 parts on each side are the same, are equal. So we're going to make that statement. Angle RAB is equal to angle BAN. I'm gonna put the measure of. Put those little M in front there. What's our reasoning though? It's a definition of bisectors. All right, from the definition, we know that those 2 are angles. Definition of bisector. Again, there's our framework. Now we can fill it in. RAB is X, so I'm going to say X equals 2X minus 75. That's going to be substitution. We're going to solve for X. I'm going to minus 2X on both sides. We get negative 1X equals negative 75. That's the subtraction property. Lastly, what I need to do here? Yeah, divide by, not X. Yep, divide by negative 1. So divide everything by negative 1. X is going to equal 75.